In this video, I'm going to go over series circuit calculations. You can see here that I have a battery, I have a switch, I have two resistors, some grounds that lead back to each other, and each of these have values. So the battery has 12 volts, R1 has 3 ohms, R2 has 9 ohms. Okay, I'm going to zoom out a little bit, and we're going to go over some of the calculations that we need to find. Always remembering that we are going to use Ohm's law to find what we're looking for in these calculations. Okay, so the first thing that we're going to do is we're going to find total circuit resistance. Okay, so we already know that that resistor 1 has 3 ohms, resistor 2 has 9 ohms. To get the total circuit resistance of resistors in series, or this series circuit, you add the resistances together. It is the sum of these. And so the total circuit resistance in this case is going to be 12 ohms. Now, to get your total circuit current, we use Ohm's law, and we know we have two givens now. We have our 12 volts, and we have our 12 ohms, so 12 divided by 12 equals 1. We have 1 amp that is going through this circuit. Okay, and that's really all there is there. Now what we want to do is we want to find voltage drop. Okay, so our voltage drop, so something else that I should mention is this 1 amp is the same throughout the circuit. So the total current that is going through R1 is 1 amp, and the total circuit, or this total current or flow going through R2 is 1 amp. It does not change regardless of the resistances in each of these resistors. Now let's go back to voltage drop. So our voltage drop, we are going to use our total circuit, we're going to use Ohm's law and our total circuit current and our total circuit resistance to find the voltage drop or voltage consumed across each of these resistors. So voltage drop is equal to amps 1 times 3 ohms for the first one, so that's 3 volts going across, or that's being consumed by R1. What about R2? Same thing. So we're going to do 1 amp times 9 ohms, and that is equal to 9 volts being dropped or consumed across R2. And that is how we get the answers in calculations for the series circuit.